PoorConsult's YouTube channel. In this video, we continue our video tutorials on Solidity and blockchain programming, and in this part 3, we have a lot of stuff to do. First of all, we start by talking about global variables, and then we'll see how we can have two contracts within one smart contract. I mean, how we can have two contracts to interact within each other, and a lot of cool stuff is waiting for us. So if you're ready for it, just get yourself comfortable and let's jump right into it. So here from the previous videos we have our code written. You see, we're talking about the state variables, the local variables. We had a lot of examples in there. We talked about variable types like strings, booleans, signed and unsigned integers. And for now we need another thing, which is global variables, and for that you can actually read the documentation. I'll post the link down below. You can go and see the global variables for Solidity. See that most of them are starting with like block dot something and that msg dot something, value sender, block dot time, and stuff like that. So these global variables, they are already in the blockchain, okay, and our smart contract, it does have an access to them right away, so we can use those global variables to pass some information, be it at the state level or at local variable level, I mean within these functions. So we can use those global variables and they are already there on the blockchain. Okay, so I understand that theoretically it might seem confusing, but once we have an example you'll get it all. So for us, for now, let's just what we do, let's delete all of this that we have written on. Okay, let's have a new example. Let's call our contract, let's call it, I don't know, my test. Okay, my test. And then in here what to do, let's have state variables, some, yeah, let's have unsigned integers. We already know what are they store numbers within them. So unsigned integers that have a public, so as we can access it and anyone can access it once it's deployed on the blockchain. Let's give it a number, so number 20. So this unsigned, this number variable will store a number in it which equals to 20. We assign it a number, and then we have let's give it some do some booleans, like boolean. Again, let's go done. Okay, something that is done, true or false. Let's give it an assigned a value of true. You know, you remember, yeah, if we don't assign a value, by default it goes to false, so let's give it a true. Okay, so that's it. And just for you to show that so we can try to have a function with the same variables, but in this case we'll try them to, I mean, the similarly written variables, but they should be local variables now instead of state. So let's call our function, you will understand now. Let's call it our first function. Okay, first function, and then the first function, make it a public again, open curly braces, and again unsigned integer 256. Let's give it a number, yes, as a local number, make it equal to 20 again, and let's have again a bool. Okay, let's call it local done. Okay, something like that, just for you to show that these are locals unlike the first ones. Again, equal to true. Okay, and now so far we good. Just, yeah, warnings because these are again unused variables, but okay, we don't worry about it. Now if we want to use the global variables, for example, let's try to use this time. Okay, the block.timestamp and msg.sender. So what we do, we come up here at the state level and we can add again, so it's a number above time, it's a number to 256, call this variable a time and assign it to block. Yeah, it was block timestamp. Yeah, timestamp. So that's it, our global variable. We can comment it and you remember this sign, yeah, to double slash to comment, to write some comments, so as later on when you come back to your code you have a good understanding of whatever you have written there. It's very important, guys, because one day you don't write, second day you remember, a week later remember, a year later you should read your code stroke by stroke to understand it. So it's important to write something. Just for example, I'm just showing to you, it's a global variable here, global variable. Okay, and for msg.sender, so we can, let's have it a type address. So again, this is address, so keeps an address, the Ethereum wallet address of a, if we're gonna pass Ethereum wallet address, later on I will show you how to write it down, but for now just remember that it has a type of an address, just like we have type of booleans, integers, strings. Now we can type address, let's call it the sender address, okay, and give it msg.sender. So what it means is that once the contract is deployed, and then somebody can call our local function, this first function. So once he calls this function, whatever this function does, yes, some tasks it does, once he calls the function, so whatever address is being passed through, that's this msg.sender address. Okay, so let's say our function I don't know, transfers some amount of funds to the address specified in here, and whoever calls this function, whatever wallet he uses to call this function, so that wallet address is this msg.sender's address, okay, because that is being passed through. So this is a global variable, okay, msg.sender. It can be used at the local level, at state level, whatever. It's just the msg.sender. We can use it when, say, let's say we can use it to show that we are the owner of this contract. So once we deploy, we can say that the msg.sender gets a fee, let's say a developer fee of 10%. All right, so who's this msg.sender? It can be the address that deploys the contract if it's mentioned in the proper place, okay, but just in here it's in the local function, and it does perform some sort of task, whatever our function has to do. Okay, just for you to know that these global variables can be assigned in our smart contract. Is that, let's say we have one more contract within our this sheet. Let's say we're gonna write one more contract, and then we want the second contract to inherit from this first one, meaning that we want them to use all the features written in here and then add some more on top of it. So how are we gonna do that? Let's say we can write contract, again the name contract. After this, make sure you go below these curly braces, okay, because it's a separate contract, and then we call it my second, let's say, test. Okay, my second test. All right, and then so what we do is this is a contract, okay, we open it up. However, we need to understand that because we want this contract to inherit from the first one, meaning that all these functions and functionalities we have written in the first contract, we want this contract to use all these features. So we need to write down is, and then type down the first contract's name, which was my test. Okay, if we save that, we see what is it complaining about, as not found or not unique identifier. What identifier? My test. Okay, so there was a typo in here. Hopefully you didn't do that mistake. All right, now we save it, we see that it's working. Okay, so it's compiling successfully, and this is important because you might ask, why do we need two contracts? Is because sometimes if we are writing down the smart contract of our project, we might use some ready-made code samples. We might import them. For example, if we are importing like Chainlink oracles that we're gonna talk about later on for these data feeds of off-chain data feeds, or some other like NFTs we are importing in our smart contract, we want our actual smart contract to use all those features from our imported smart other contracts. Okay, so that's why this is the syntax of how to write it. We say contract, and then the name is and then another name of the contract you want to inherit from, you want to use the features from. Okay, so in the example now you will understand it. So first of all, let's see that it's complaining about all these unused variables. So I'm gonna comment it out for now, so as it doesn't disturb us, even though it's working properly, but just not to let it disturb us. So for now, if we, I mean, it's compiled, yeah, and if we go, we want to deploy, we see we have these two contracts now we have. So if we try the first one, okay, let's delete whatever we have already deployed, and then we try to deploy it, we'll see that we are having these two functions. Okay, the first one is this first function that we have deployed in our myTest contract, which obviously has 0 value, we can call it, but everything is commented out. And then for the first one, because in here we have assigned it a public, and once it's public, you know that the state variables, once being public, are automatically generated the getter functions. So if we click it, we'll see the value of 20. All right, if we, but however, if we add on, let's say for this instance, if we delete this instance and then we add public in here, we save it again, and then we deploy one more time, we should see now 3 getter functions for this boolean as well. Yeah, so the boolean done is true. If we click on it, we'll see the value true. Okay, so that's it. But if we now, for example, let's delete it and try to deploy our second contract that we have just written in here and see what it shows us. Okay, let's see. If we deploy it now, then we're gonna see, all right, now look at it. Even though this contract has nothing in it, all right, no variables, no functions, it's just empty. However, because it's inheriting from this first contract, then it also has all the features that the first contract does. You see all these functions and they are working properly. All right, so you see them, it's working. So this is important thing for now to understand that once it inherits, then it uses all of those functions from the first contract. However, in here we can also add, let's say unsigned integer 256, let's call it a new number, and then assigned it a value of 459. All right, this is our number. Now if we give it public, we make it public, and then if we save it and delete the first deployed contract and now deploy it once again, then we'll see now we have 4. All right, now we have 4 getter functions for this new number. If we click on it, 459, we get it. So it means that we got not only the getter functions from the myTest contract, but also on top of it we have the new variables and functions that we are gonna derive in our myTest contract, which myTest contract that also, apart from itself, it also uses the features from the first the contract. So that's it. You need to know is that if we declare this, we change the type of the variable, let's say for our boolean, yeah, if we call it private, and the reason why we do it is because maybe we don't want this variable to be seen, I mean the value of it to be called from anyone else. So if we declare it a private, then our second contract, my second test, won't be able to access its value. Okay, so let's check it out first. If we come and if we deploy our second test, we'll see that we have only first function, we have a new number in here, and then we have a number here from public. So this our boolean is gone now because this second contract cannot read its value. All right, so this is important to understand. And then another type of, we have public, private, we can also have internal. All right, internal, and yeah, actually let's before going to internal, let's have another bool in here. All right, we say bool, and then it's a public, and then again let's say done, and then again true. All right, so look at here, if we save it, we see that there is an error. Okay, so because it's not semicolon, now you see there's no error. Why? Even though you might think that this is the same, bool done true, but because the types of those variables are those state variables are different. This is private and public, so they not contradict within each other, and we can deploy it right now, and we can see that it does read our this boolean from the second contract. This is my second test. Okay, so it shows us true. However, if we were about to change this private into public and then try to save it, we see we have an error saying that it can't be two of the same type. I mean, everything is same in here, so these are like conflicting with each other. But when we give it a value of private, then we have obviously no problem, because this second test, it cannot access these variables from the first contract. Okay, I hope it makes sense. And the last part, the last thing you should know is that there is another type which is internal. Okay, we say internal, and once we say it internal, it means again this okay, let's show it first. If we delete it and if we deploy again, you will see that we cannot access the contract is deployed, but the end user cannot access it. Here, where is our time? You see there is no time. Time disappeared because it's not public, it's internal. However, unlike variables of private type, internal ones can be, though their values can be accessed from the contract that is inheriting from them. So from this contract, my second test, we can have an access of this variable because it's of type internal. All right, and to show that, we can write down again 256, and then give it public, and then call it this time, let's say our time our time, the new variable, and we make it equal to the time, to the variable written in here, so time. And now if we save it, we say it doesn't give us an error, which means that this our new variable called our time, it should read the value of this variable time, which is internal, and this time internal in this contract it didn't show us, right? You saw it here because it's internal, it's not public. However, this one, the second one called our time, this is public, so when we deploy it now, we'll be able to have an access to it, and its value we have equaled it we have assigned its value to the time, which is in here, and equals to this global variable called block.timestamp. So if we'll try to deploy it, if we try to deploy our second test, we'll see that now we should have an access to here. You see our time, and if we click on it, we see the value that is being passed through this global variable block.timestamp. Okay, so this is how to get an access to those internal variables, the variables of type internal, which are not designed for the end user. You can't access it from outside. However, within a smart contract, if you have like different contracts which are inheriting the values from one other's values, then you can basically just write down and assign the type of internal to this variable, and then have another contract have some other variable inherit from it, read its features, its values, and basically you can have it deployed, and people can then access its value. All right, so I do understand that this might sound a bit boring, but this is really important to understand at this step, and later on, once we start actually doing examples and writing down the real the smart contracts with real use cases and decentralized applications, then you'll see that how easily we're gonna use all of this knowledge, how we're gonna apply it in actual examples, and you will definitely have much fun. All right, guys, I hope it did help you to understand a little bit more Solidity and get one step closer into being able to write your own contracts, even though we are yet far away, but hopefully we'll get there soon. So if you like the video, press thumbs up button. I really appreciate it, and get subscribed if you haven't done it yet. And in the next video on this topic, we'll continue and see whatever else we can achieve, and some more knowledge we can get. Thanks, and have a good day.